Hello everyone and welcome back. Today we will speak about the difference between scalar and vector quantities. Okay, so what are scalar quantities? Scalar quantities are quantities that have magnitude only. Magnitude is simply defined as a number in a unit, and we've seen in the previous lesson what exactly are units and how to measure them using the different quantities. Look at the following example. Let's say we have 6.5 meters per second. 6.5, that's the number, and meters per second, that is the unit. So together give us the magnitude. On the other hand, a vector quantity is a quantity that has both magnitude and direction. Again, magnitude is number in unit, but now we also have a direction component as well. Look at the following example. The following example, it says 6.5 meters per second at northwest. So the magnitude is, we said, the number in the unit, 6.5 and meters per second. And then northwest, that is a very general direction without giving any degrees. So notice how in order to describe a vector quantity, you need direction as well, whereas a scalar, you do not. Allow me to put it simply in other words. Let's say we say an object has a 5 kilogram mass. You don't need anything else to describe it. You just need the number and the unit, the 5 and the kilograms. Therefore, it's a scalar quantity. A direction would not make any sense. Okay, so how do we show direction in a vector quantity? Well, there are two ways. First, if it's one-dimensional. Imagine if it's one-dimensional, imagine simply a ruler. You can either go forward or backwards. So you would either put a positive or negative in front of the number. So for example, let's say you have positive 8 meters. What does that mean? That means that the person, for example, moves to the left 8 meters. Whereas if you have negative 8 meters, it means that the person moves to the right, the other direction, 8 meters. What makes positive or negative left or right, that is completely up to you. As long as you put one direction to be positive and the other direction to be negative, you will always get your answer correct. And if it's 2D, remember it's got to go along X and Y axis. So you're going to have a combination of north, south, east, and west. So as you can see over here, it depends on the angles by which you're going to use to represent it. It's got to be a combination now along an X and Y axis, therefore a north, south, east, or west. So allow me to please demonstrate. So let's go to our board so we can chart it out. So now, imagine we are showing this angle right here. So this direction right here. Right here. So what would that be? As you can see, it's going to be north of east, so we call this north of east, because why? It's north of the east. This angle right here, it is east of north, so it's symbolized as EN. This angle right here, that is west of north, and is symbolized as WN. This line right here, it is symbolized north of west, and it's NW. This angle right here, it is southwest and is symbolized as W. And if you're referring to this angle over here, it's going to be west of south. This one right here, east of south, and this angle right here, south of east. Now, this diagram is good to know. However, 95% of all of the questions on the regions are going to involve these two angles right here. Some kind of combination of north and east. Very rarely do we see like a north and a west. So if you know these two right here, you guys are golden. So once again, if it's rising from the east, that's going to be north of east. And if it's to the east of north, that's going to be EN. Now, going back to our presentation, the last thing that we have to discuss is how to actually represent vectors. Vectors are represented by arrows, as you can see right there. The magnitude, which is, we already said, number in unit, is represented by the length of the arrow. So imagine we have two magnitudes, one is larger than the other, so the one that's longer represents the larger quantity. And direction is simply represented by the arrowhead. A lot more on vectors to come. Thanks so much for joining me. See you in class.